Here we are at example 5 from our 8.3, number 27 notes. We're asked to graph this following rational function. And typically how we start these out is just by looking at the horizontal asymptote. So we're going to look first for our HA. And we do that by looking at the degrees on both top and bottom here. We're in the scenario where we see that the degree on the bottom is slightly larger than the degree on the top. And as a result of that, this entire rational function would follow the horizontal asymptote where it's y equals 0. There's no other k value, so like we don't have this rational function plus maybe like a number like 2 out here, in which case that might change our horizontal asymptote. You would just take 0 plus 2 and get that new horizontal asymptote. So this is out actually our final horizontal asymptote. Next, what we're going to go ahead and do is we can't really necessarily determine if there are any holes or vertical asymptotes. The horizontal asymptote is really the main item here where we can just look at our original, rational function and determine some things just kind of immediately. But for our vertical asymptote, we could end up with maybe some potential holes there. So we can't just start definitively looking at the bottom and setting that not equal to 0. I mean, you can, but there's usually a better order, and I kind of like to stick to what I think might be a reasonable order to kind of go through. So next, what we would do is we're going to go ahead and factor both the top and bottom to see maybe where are our holes and where are our vertical asymptotes. So just looking at the top, we'll factor him first. It looks like this can be broken down into x plus 3 times x minus 2. The bottom, it looks like we can pull an x out of every single term. We'll go ahead and do that. And when we do that, we're left with 2x squared, because we pulled a single x out of this first term, plus 5x. Minus 3. So again, just pulling an x out of all of these individual terms. It looks like we can possibly factor this even further. So when we do that, we have x plus 3 still on top, times x minus 2. On the bottom, we have x on the outside times 2x. And I know the other guy has to have an x. Looking at these, I'm going to make him 3 and him 1. With 1 times 3, we get 3. I know that one of them has to be negative because they multiply to be negative 3, but also add up to be 5. Now this 2 is also playing a role there, in which case I'm trying to get more positives than negatives, so that middle term is positive. And as a result, if I were to make 3 positive and this guy negative, we would end up with 6x, negative 1x, boom, there's 5x. Also, when you multiply the last two, you do obtain your negative 3. So this is now our final factored form for that bottom. Now, in looking at it, we can recognize pretty quickly that there is an x plus 3 on the top and an x plus 3 on the bottom, and those would actually just end up canceling out. So our final simplified version of this rational function would come out to be f of x is equal to x minus 2 over x times 2x minus 1. Nothing else can cancel or drop, so this would be our simplified version of that rational function. Now, just because something did cancel does not mean that you can't have this piece not equal to 0, just like we normally found with vertical asymptotes. Because if we did say that x was negative 3, well, boom, right now that bottom is 0. So you still follow this by setting this not equal to 0, that entire bottom, including the piece that got dropped out. The only thing, though, that x plus 3 with that cancellation that happened is instead of a vertical asymptote there, what we see is that hole. This guy is still going to be a vertical asymptote, that 2x minus 1. Likewise, this x, even just kind of by himself, is still also a vertical asymptote. So again, the cancellation just determines that we have a hole there. Setting each one, now looking for those vertical asymptotes and holes, we'll say that our x is not equal to 0. These are our VAs. X cannot be 0. Our 2x minus 1 cannot be equal to 0. Solving for x from here, we just add 1 to both sides, and then with 2x cannot be equal to 1. So x cannot be equal to 1/2. Now again, that is our vertical asymptote. Switching gears now toward the hole, we know that this x plus 3 that got canceled earlier cannot be equal to 0 still. Just subtracting 3 from both sides, we end up with x cannot be equal to -3. Now the x value cannot be equal to -3. We found the x value for which it can't be. But what we need to really do is determine what is the y value, because again, we are talking about a hole with an x, y coordinate point. Now how we actually find the y value, we just simply plug in to our simplified version. So that comes from this simplified f of x is equal to x minus 2 divided by x times 2x minus 1. This actually should have been 2. There we go. So just again throwing -3, that x value that it cannot be, into the simplified version, we end up with -3 minus 2 over -3 times 2x, instead of x, we're throwing -3 in there. So times -3 minus 1. Looks like we'll end up with -5 on top. On the bottom we have -6 minus 1 is -7 times -3, so -7 times -3 comes up to be +21. There we go. So for our hole, it comes up to be a pretty ugly point at -3, -5/21. Now looking at our slant asymptote, just even first determining if we have any or not. We notice that the degree is not larger on top than it is the bottom, and as a result we won't have any. So here we will have none. And finally, looking for our x-intercepts. So to find the x-intercepts, what we're going to do is set our simplified version equal to 0. And again, we're looking for this x-intercept where it's crossing this x-axis, and that's exactly why we can set f of x or y equal to 0. So 0 is equal to our simplified version of the function, this x minus 2 divided by x times 2x minus 1. Then we're trying to solve for x from here. So if we go ahead and multiply both sides by the entire bottom, we end up with x times 2x minus 1. On the right side, we would also have to do the same thing on the left. On the right side, they will just cancel out. 0 times that x times 2x minus 1 just still becomes 0, equal to x minus 2. So it looks like we will see a cross, or x-intercept I should say, at 2. So for our x-intercept, we will see one at 2, 0. The final item that we need to check for is to see if this actually crosses a horizontal asymptote. Our horizontal asymptote is 0. So we have again our horizontal asymptote. We'll go to green. So checking to see if the cross happens. We're going to take our horizontal asymptote, which we know was 0. And we're also going to take our simplified version of this function. There he is. So we also then have our f of x is equal to x minus 2 over x times 2x minus 1. Yes. So again, pretty much y equaling 0 is the same thing as saying f of x is equal to 0. So we're just going to take 0, pretty much throw him into this entire left side, because f of x is the same as 0 now. Again, we're trying to pretty much just see the intersection of our horizontal asymptote and our simplified version of the function. That's why we can go ahead and see pretty much what we're doing really is a substitution method here. Multiplying both sides by that x times 2x minus 1. Over here they came. Leaving us our x minus 2 is equal to 0 times that piece comes out to just be 0. And as a result, looks like x comes out to be 2. So it will cross. There is a cross going on here. And it happens specifically at x equals 2. In fact, we also know the y value. It is literally the y value from our horizontal asymptote, so in this case it's 0. It's interesting to see that our cross specifically happens at our x-intercepts. Happen to be the same exact thing. All right, we've covered everything now. We've got our HA, we've got our VAs, plural, the whole, the SA, X-intercepts, the cross, man, lots of different little pieces to kind of throw together on the same graph. I'm going to go ahead and do my best, and the reason I'm going to say that is because we notice two vertical asymptotes incredibly close to one another, but we should be able to reasonably manage. So there's our HA. Now going to our VA. Might be a little hard to see, but it literally is on that line. The y-axis, or x equals 0. The half. There is our other vertical asymptote. Next comes our whole happening at -3, -5 over 21. So the whole is at -3. -5 over 21 is pretty close to 0. It's almost a fourth, -1/4, so he's about here. And SA, we don't have any x-intercepts to 0. Also happens to be the crossing for our horizontal asymptote. Looks like our disappeared. So -3. There we go. And that's pretty much everything that we have crossed off of our list. Pretty much now just graphing this item. You can plot a bunch of different points, but the general shape of what this thing should look like would do something like this. Then it's going to come way up here. In fact, it's really almost like off the graph. But it's going to kind of go back upwards. And on the right side, it will come down. Start from the down. go through that point, cross that horizontal asymptote, and then finally it will start to hug that horizontal asymptote. So more or less, this would be what our image for example 5 would look like. Again, though, that is example 5 from our 3.8 number 2 set of notes.